Okay. Well, hi guys. I'm going to talk to you about CakePHP in a containerized environment today. So CakePHP and Docker. First, I'll introduce myself. My name is Stefan van Gastel. Must be very easy for you all to pronounce. I'm from the Netherlands. I live in a very small village called Zundert, on the border with Belgium. So I'm okay for drinking Belgian beers. It's the birthplace of Vincent van Gogh, and you all must know it from the largest flower parade in Europe. I'm using CakePHP since version 1.2, so that's about 8 years now. Okay, Mark is confirming it, very good. And I've been attending CakeFest since 2012. I believe that was the second time Manchester, with the exception of the previous CakeFest in New York. So, I work for the Dutch Ministry of Defense. We've been working there, actually I've been only working there since 2006. Currently I am technical lead for mobile apps for military police. Our ministry consists of both Navy, including Marine Corps, Army, Air Force and military police. And our military police has recently been expanding, getting some special forces platoons, counter-terrorism special forces platoons, given recent events in Europe. Well, you know, these boys and girls, they got promised a lot of new equipment, better vehicles, armored vehicles, better equipment, better weapons, and of course, better IT. And when upper management says better IT, you know, you gotta recognize this. They say, okay, we're gonna give you apps. Yeah, everyone wants apps. And it has to be really easy because I can download Angry Bird and it works. And okay, so you guys, you're gonna build apps. Okay, cool. Apps to show near real-time, confidential intel on an iPhone. So. Good luck. So as a technical lead for mobile apps military police, I'm in charge of any decisions made for front-end, back-end, services, infrastructure, and architecture, because as you as a developer know, there is more to an app than just an app. For the record, I'm not this kind of guy, so I am a civilian working for the Ministry of Defense, and a nerd, actually. Before I'm gonna go into the container question, I have a question. How many of you are actively using containers at work? Okay. Not a lot of hands. It's very good. It's actually not good, but it's very good for my talk. How many of you are running containers to consume applications? So I want, say you want I don't know, a GitLab or a MySQL database, and it's very easy to run a container to use it. Okay, even that. So I guess how many of you are distributing applications or services they build using containers? Okay. That's not a lot. I actually see 2 hands. Okay. Well, very good, very good. Well, what are containers? The easiest way to explain what containers are is to compare them to virtual machines. And personally, I don't like to compare them to virtual machines because they are absolutely not virtual machines. But it's very easy to compare. So, okay, let's say a virtual machine, when you want to deploy your standard CakePHP application to a virtual machine, you'll get a maybe Windows server. I hope not, but okay, maybe you'll get a Windows server that's like 10 gigabytes in installation size, or you'll get an Ubuntu Linux server that's 4 gigabytes in installation size. You'll install some binaries and libraries, PHP, a web server of choice, and you'll deploy your maybe 100 megabyte application into it. Yeah, we've measured this at our own installations of some of our CakePHP APIs, and we came up with an Ubuntu 16.04 server, which spanned, I believe it was 6 gigabytes to run our 15 megabyte application. Well, that's quite a number. Containers don't have a guest operating system. It's that simple. Containers use the host's kernel. They get direct access to the host kernel in a secure, isolated fashion. So they don't require a guest operating system. So no memory usage for your guest operating system, no CPU usage, no disk, nothing. That's really short, and I hope you've all read the text by now, but that's a really short explanation of what containers are. So it's completely different. I don't have the time, or it's not my focus to go into detail on what containers are. You can very easily Google it, and you'll find out. But the main thing is they vary in oftenly a positive way. In speed, they start instantly because they hook into a running kernel. They don't have to boot anything, so it's milliseconds. Resource usage, if they don't do anything, they don't use resources. Footprint, like I said, we've compared it. I don't know if it's this slide. Yeah, we've compared it. We have a 6 gigabyte Ubuntu server, and we have exactly the same functionality in a 125 megabyte container that starts instantly. So that's a bit of a comparison. And isolation. It's a technical thing, but it's a very different way of isolating your processes. Well, why do people use it? And what is Docker compared to containers? Because containers are a technology, and Docker is a tool set built around containers. They often are, named in one sentence. You either say Docker or containers. You'll see me use it all the same. But Docker is containers. Containers are not always Docker. There are more container engines, like Rocket or Open Container Initiative. It's not per definition that if you say containers, you say Docker. Docker is the world-leading container platform, though. It's a standard. Developers use it, and that's part of the reason why we started using it, to eliminate the works on my machine symptoms. You can use Vagrant. Vagrant is still virtual machine based. So if you have a lot of, for different client Vagrant boxes, you'll get a lot of disk space, you have boot time, upgrading, etc. So we use it to have some very lightweight works on my machine elimination. Operators use it to run and manage apps side by side in isolated containers. The big pro for using Docker in production is developers are responsible for delivering the containers. So they deliver a container as you would, set up an entire virtual machine, transport it to your ops guys, and say, okay, start this. That's all you have to do with a container. So it makes life very much easier for operators. I'll get back to that later. What can we do with containers? Well, they serve different purposes. You can, first of all, you can run them on any operating system that has a recent Linux kernel. So that includes all the new Docker optimized, super minimal operating systems like CoreOS or Rancher OS, or SurOS, that are like 50 megabytes in size as an operating system. Use hardly any RAM or CPU. So you get a lot of compute density. Well, what can we use them for? Well, we can use it for application containers. So you can run an application server and your application inside them. You can run a data container to store your data. Not in the container, but to provide a portal to store your data in, MySQL or MySQL or SQL Server, whatever. Or you can use them to provide a very easy way to, let's say, have job containers. You want to run a job, but you don't want to install an entire VM for that. You can just start a container, let it do its job, and then close it again. Let's say image processing, large-scale image processing. And because they start so fast and are so efficient, you can start 10,000 of them to do jobs. Let's say get jobs from a queue, execute those jobs, and then close. And it will cost you the resources for those 10,000 containers to run, do the stuff they need to do, and close again, all in seconds. Okay, So I'm not here to talk about containers in general or CakePHP in general. I really wanted to focus on how do we apply containers at the Ministry of Defense and why did we do it? And what did we learn? So we've been using containers for over 10 years. These kind of containers. And why do we use these kind of containers? Well, actually they're very similar to the containers, software containers I want to talk about. They solve most of the same issues we have in software development. Because these type of containers contain physical server racks, etc. But they are used to deploy to locations that have hardly any infrastructure. As you can put one of these in Iraq or Afghanistan, where there is literally nothing, sand, that's it. So you put a generator beside it, you plug it in, switch the flip the switch, and it's running. It's contained in a standardized size. So there are global agreements on what size should this container be, so they fit on a ship. They pack everything required to run. Yeah, so everything that you need to have a mini data center is inside this container. And when we deploy this way, there are multiple containers like this next to each other. Okay, so they show a lot of similarity to software containers. And they are redeployable. Docker containers we've been using over a year now. So why did we do that? Why did we start using containers? Well, especially to I started using containers to get clean CI environments. So we had continuous integration. We used Jenkins to do that. We had a dedicated build VM we used to build all of our projects. That's kind of a dirty way if I look back on it, but improve yourself. So we built one project, and if another project had required more Apache modules, you install those Apache modules, and some other project that got built there had conflicts on it. It was very messy. It was just horrible. So what we did is we implemented containers to use in our continuous integration pipelines. So every time our project got built, it got a clean, nice and clean, fast server environment we could execute our build on, and it would do the build, do this job, and get cleaned again. Before I'm going to show you how our pipeline looks and how our cake moves, I want this to soak in. Everything we do, development-wise, deployment-wise, everything we do at work, we do without internet. Yeah, so we have no internet connection. Everything has to be super secure. It's a fortress. Nobody gets in, and everybody that's inside we trust. It's very old-fashioned, but this is the way the MOD is organized. So we can't use internet-hosted services. We can't use GitHub. We can't use Slack. No NPM. No Composer. No Packagist. We can use Composer with a very dirty proxy. But okay, so that bear in mind. So where does CakePHP fit in? Most of our applications, like I said, with the purpose of distributing near real-time intel, consist of a Cordova front-end app that is nothing more than a viewport to a website or a web application we run on the intranet, built using Angular. That connects to a CakePHP backend. So we only build APIs in CakePHP these days. The front ends we build in Angular. That get their data from a lot of sources, varying from SharePoint, Oracle, wiki pages even, REST APIs, afraid to say about SOAP APIs even. They aggregate that data, they transform that data and send a unified response back to the application. So that's how we are building a service structure using CakePHP. We've Dockerized two things, the back-end systems and the front end. Those are the two things we build, we maintain. So that's the things that are the things we can Dockerize. Well, how our cake moves. We move our cake by, we develop, and when we develop a feature, we commit and push that to our version control system. That version control system triggers a continuous integration pipeline that starts a set of jobs. And the first job is to build the application. And when the application is built, what we do is we get what we call base image, so a base container image. For example, Ubuntu 16.04 we're using now, and Alpine Linux. And Alpine Linux is a very minimalistic Linux distribution optimized for use in containers. Alpine is like 10 megabytes in size, has absolutely nothing, and you can build on it. But it's very, very small. We've built CakePHP Alpine containers that are around 50 megabytes, being fully functional. Okay, so we get a base container, we put our cake on it, we do a lot of composer installs, etc., we configure it, and we configure it to be a fully functional container. So if I would start that container, I would get a CakePHP application visiting its mapped port. When that container is built successfully, we push it back to our GitLab container registry. We use GitLab for being able to be installed offline and on-premise, and it's an awesome product. So we push it back to the GitLab container registry, and the next job is initiated, which is test job, and which pulls exactly the container that was built, that is in the registry, and starts running tests on it or against it. Yeah, so we use Behead for our end-to-end API endpoint testing, or our endpoint testing, so that those tests will run against it, and PHP unit to run inside the container to test it. If that all succeeds, well, next phase, you get the picture. A container is pulled again, tests or checks are ran against it. We use SonarQube to enforce programming standard PSR rules, and Coverity to security check it. Yeah, security is a hot topic, of course, everywhere, but in our case, especially. And if that is successful, we go to a review or staging phase. Depending on the Git branch we're in, we use an enhanced Git flow. We use a review or a staging phase. We use Rancher, another awesome product for managing clusters of servers to run Docker on it. So it's a container scheduling and orchestration tool. And a review or staging environment is always created. Every commit, such an environment is created. Every merge request, we get a merge request or a pull request, and people can judge a merge request or review a merge request, and always a link is provided to okay, these are the changes, these are the discussions, and click this link if you want to see the environment running in this state. So it's very powerful. Okay, how does cake get eaten? Well, unfortunately, the same old way. So we have all this fully automatic development test phases, and when we go to production every 12 weeks, which is a lot for our terms, twice a year is kind of the standard release calendar. So when we release, we still do it old-fashioned way. So we give them a Git tag. This is the new version. Check it out. Run the installation manual against it. It's just the same old shit every time. This is one of the points, getting to the lessons learned. We really need to change. As a development organization, we are a really hierarchy-based organization. So as a development organization, we really should spread the word about containers and get hosting or operations aboard. Because we can say, oh, we're going to use containers, and they'll say, what? Bringing me to the first lesson learned. Well, it's nice you guys want to use containers, but first of all, what are they? Second of all, what's in it for me? So why should we use containers? Yeah? We're all government people, so it's all really relaxed, and we've been doing the same stuff for 20 years now. It works. Why should we improve? So yeah, there are 3 aspects to the mindset. Like I said, first, what's in it for me? Yeah, you really have to get out there, and that's a big part of my job these days. You know, spread the word. Why should we do this? Why? Why? How can you get better using containers? Second of all, is make sure people have time to learn and explore, because they're all swamped in work and don't have time to do anything else than their primary tasks. And the third one is, if you want change, and we've seen the word change come around in the previous talks, make sure it's carried by the people that are affected by the change. Yeah, it's very nice. Some top management dude read a Forrester or Gartner report that says you should do something with software containers, and then says to all his people, guys, you should do something with software containers. Just doesn't work. Second lesson learned is 12-factor apps. Feel free to read the quote. 12-factor apps really are required to make CakePHP work in a containerized environment. Just plain simple. I've taken 3, and I'm running low on time, but I've taken 3 that really are required. First one is configure everything through the environment. You know, containers are vehicles that are configured almost purely through the environment. So start using that. CakePHP has awesome environment configuration support. Second one is backing services. And backing services can be configured using data source names. So configuration, I've shown in the examples, this is hard, below, configurations using URLs, URL formattation. They can be injected into containers using environmental variables. Using DSNs, most of all, saves you a lot, setting a lot of environment variables. So not setting the MySQL host, MySQL user, MySQL password, etc. You can configure it using one string. And the third one is disposability. Last year in our lovely city Amsterdam, I've seen Quinten Adam give a talk on PHP deployment 2016 flavor, and it was really a personal eye-opener and confirmation of a path we went on, and kind of a confirmation it was a good path. And that he said code should be stateless. Yeah? As you can see on the top right, code should be stateless, and your application should not save any data on the same file system. I believe Mark told about the file system yesterday and saving data. I saw on Slack. But make sure your application is stateless. You can start it, throw it away, start another one, another instance, and everything should work. Core concept of containers. So splitting data and state. And the third one is containers are revolution, not evolution. And with that, I mean going from bare metal to virtual machines. I personally think is evolution. You know, you install your operating system on a bare metal machine, you install it on a VM, and from there on, you know, your process of deploying applications and building applications is practically the same. Your infrastructure is different, but you know, whatever you do after installing your OS is the same. When you talk about containers, you have to change the way you think about building your applications. It's the same as building for a cloud platform or a PaaS platform. And don't underestimate the technical depth that you get. You know, when you run on a VM, you only get when you run on a VM, you only get the top 2 layers with an operating system. But when you start using containers, you have to think about a container engine. How are your services getting discovered? How is your cluster getting orchestrated? And optionally some workflow. And eventually your code is different. So you don't have to use all of these tools, but you have to know, okay, this is there is a lot that comes around when you want to use containers, especially in production. Then I wanted to show you a slide demo, trying to mirror my display now. I have a GitHub repository that is called Docker CakePHP with a very simple Docker file. Docker files are the building syntax for creating a Docker container. The link I have in the presentation, and the presentation is on speaker deck. What this file actually does or says is, okay, take a Ubuntu 16.04 base image with this, which is nothing more than a cloud image of 16.04. apt-get update and apt-get install some packages like Git, Composer, libapache, 2, mod.php, using Apache 2 because it's very simple compared to Nginx or something, which also installs PHP 7, get some PHP packages required for CakePHP, some nice tricks for keeping your container small. So you build a container once, you run it, you do whatever you want with it, you don't upgrade it. You know, I've seen operations engineers trying to get Puppet to work inside a container. It just broke my heart. No, and getting authorization for SSH login inside a container. No, you build it, you run it, you have a new version of your application, you build it again. Okay, so we do some Apache configuration, mod rewrite enabling. All these run commands are ran inside the container. So Docker starts a container, runs it the command, which is basically one just a command line command, commits the change, and it does this for every run step. So I clean the Apache root directory, clone CakePHP app, change the work there so I don't have to cd into the directory every time. Composer install, copy the default app. You know, I've explicitly manually done this here. So no Composer create projects, just to be able for people who want to use it to see it as an example. So copy the app.php, replace some variables so it works okay, change permissions, expose port 80, which basically says if you run this container, you can only connect to it by port 80, and start Apache in foreground. Okay, I'm going to show you this, what has happened to my, that should be bigger, okay. I can say docker build, tag it CakeFest in the current directory, where this Docker file I just showed you is, and it should take it from cache, very good. And you know, normally this takes longer, and it just executes all these steps inside a container. Moving on, sorry. And now Docker images tells me there is a CakeFest image, which I created 2 days ago, and is 377 megabytes in size. Well, for the demo, going through, I'm going to start this is in the README of the same repository. It's an example how to start a separate container. That has started now with MySQL Server, and given it the name MySQL Server. I know it's all going a bit fast, but Megan's going to be mad at me if I don't. What I'm going to do now is I'm going to start a CakePHP container. I say map port 80 of the container to my own port 80 of my machine. Give it the name CakePHP. Inject, I hope you can read this, inject an environment variable called database URL, which is the one CakePHP provides. Give it this data source name. So I say protocol MySQL root user secret password at MySQL server, and Docker knows the host names of all containers it's running. So if I run a container and I call it MySQL server, the other containers can connect to it by using just the MySQL server host name. It's very powerful stuff. I give it this is the environment variable I provided in my Docker file. So I say use database sessions, so I can run 10 of these containers, and they all use the same MySQL server to source sessions. Okay, I'm going to do that now. And I'm going to say, what container do you want to run? CakeFast. Okay, it's up. And I should be able to visit my local host, showing CakePHP in a container that is connected to a database. Again, apologies for being so fast. But that is, in essence, all you have to do to get CakePHP in a container and run it scalable against a MySQL backend. So I have some resources. Again, this slide will be shared, or these slides will be shared. There are some pretty good blog items about it. I have a repository, like I said, in the top. Its purpose is an example. There are some other images that are pretty good for production usage. Please read up on Docker. They have awesome documentation on best practices, on simple tutorials, etc. And that's a bit fast. First of all, please provide some feedback on joined in. Any questions, contact me after in the breaks or whatever. I am on Slack, but I'm not really active because I don't have internet at work. I do have an email address. Like I said, you can get the slides, and I would like to ask if anyone has any questions. Yes, a box will be thrown at you.
Maybe I shouldn't throw.
So you guys use Rancher to manage all your production.
Yeah.
Did you try anything else other than that to evaluate them?
Sorry?
To evaluate them, did you evaluate anything?
Yeah, we're in a kind of beta phase, running containers in production currently. So we are using Rancher. Rancher is kind of a meta platform because you can Rancher can run Kubernetes, Mesos, Docker Swarm clusters. So you can kind of choose it. So we're currently using Cattle because it's very simple zero config. We are looking into OpenShift. We have an enterprise contract with Red Hat. So they want to provide a free OpenShift environment. But it's all very, I'm the only person actually trying to get Docker to be accepted within the ministry. So I'm doing a lot of research and writing a lot of reports, but it's a kind of one-man job. So we want to look into more options than only Rancher. It's a very great product, that's for sure.
Thanks.
You mentioned that you're using a feature of GitLab. I've never heard of the...
GitLab Container Registry.
Yes.
Yeah.
Can you explain what that does?
Yeah, it's a good question. You can use GitLab. GitLab is a self-hosted GitHub alternative, which is pretty good. You can store code in a repository, and a registry actually is a repository for Docker images. So you can build your image and send it to a central place, and that's called a registry. And it's pretty smart. It works on a kind of a Git basis. So if you send two images with two different CakePHP applications that are both based on the same, let's say, Ubuntu base image, the registry recognizes that, and it won't store two exact copies. It'll reference layers. Docker is fully layer-based. Didn't have the time to go into the real Docker essentials, but it's very layer-based. So it's a centralized storage for containers.
So it's like Docker Hub, basically?
Yeah, it's like Docker Hub, yeah.
Perfect.
It uses the same software beneath Docker Hub.
Thanks. Oh my god.
Hello. So you said now it's not any virtual box anymore, but it's on the local on the host system. Do you then have problems with different operation systems? For example, does every one of you has the same kind of Unix version then, or also Mac? Because, for example, for Mac you already have the problem with case sensitivity by default if you don't know how to configure your Mac. Yeah. Or with Windows you have path issues and all other kind of things. So do they now come into play with that?
No, amongst every awesome thing of Docker, one of the best things is you can create a Docker container, and it can run literally on any system that has a Linux kernel and Windows Server 2016. It's no difference at all. So you can build a Ubuntu Docker image that you can very simply and run the same way on a Windows Server as Red Hat, as CentOS, whatever. So you really eliminate, and since all the functionality, everything is inside that container, you eliminate exactly the problems you're describing.
Thank you.
Is that an okay answer? Okay.
Hi. So I don't know. Do you have a use case where you have say multiple containers running on the same box? If you do they compete for resources, and how do you manage your resource allocation as against when you have actual virtualization set up where you actually dedicate resources to each?
Yeah, VMs have dedicated resources, so you know when you're out of virtual CPUs or out of virtual RAM. Docker does not. That's where orchestration and scheduling platforms like Rancher and Kubernetes and Swarm, etc., come in, because they schedule containers. I tell Rancher I want to run a container. Rancher decides, okay, I'm going to run it on one of these 100 or 200 host systems I have. And he looks at resource usage management, and if I run, we never run one container of an application. We always run 3 or 5 or 10, because they're so small and redundant then. If one dies, the software load balancers Rancher also provides are automatically adjusted, and Rancher says, okay, I promise you 10 running containers, one died, I'm going to reschedule this one to a host that's up or to a server that has uses less resources. And it's all, especially on all intranet infrastructure, 10 gigabyte connections, seconds to reschedule.
So when, as you mean, one container is taking a huge ton of resources, and it's impacting like other containers.
Okay.
What happens?
You can configure containers to be limited to a certain amount of CPU slices and certain amount of memory usage.
Okay, gotcha.
Yeah. Any other questions, or are you all dying for lunch?
You wrap up both PHP and Apache in one container with your app?
Yeah.
Do you put it, there's anything else? You
So
don't have, usually you have to split PHP and Apache. And
you can split it. Yeah, you can create one container that just is a data container and only contains your application code.
Yep.
That's it.
Yep.
In let's say a Alpine Linux image, it's no size at all, and you can get a PHP FPM container and an Nginx container and all connect them together.
But I mean, in your example, you don't do it.
No.
Like, is it just an example, or you don't do it in production as well?
No, we don't do it in production, and this is just an example. Yeah.
Okay.
Sometimes we run Apache and our applications on the same container in production just because we like to do it easy. But you should not do that, I guess, from a design perspective. No. This is just the example that's made as simple as possible.
Cool.
Okay.
Awesome. Thank you, Stefan.